Hey, welcome. I have a refurbishment project here. I'm going to refurbish this set of Pexto rolls. They're just a small set that we haven't used them for years because we keep breaking the gear end. Yeah, so let's get this torn down and see what needs to happen. It's been so long since it's been broke down. I don't remember what broke. So let's do that. Say fab it all.
Hello.
So here's the gear end of the rolls. The drive shaft comes through right here. It's actually pushed out. When I brought it over, the vibration popped this out. There's a cover plate on here that's been removed. And what happens is this is the main drive gear. And this is a housing we made when it broke the first time. I remember making that or doing something with that. And this already made quite a big improvement on just making these gears mesh better and not move, because I think we cracked the old one. But there's a gear that's missing here. There's another gear here. So this goes in like that. And this gear is driven by the shaft, which then in turn drives this gear, which then drives this gear. So this has been revamped. This is a lot bigger than it used to be, or not bigger, but it's solid now. It was a cast iron with kind of like a pulley, and it cracked easily. That was the first thing we changed. And then we cracked this housing, and so we redid that. So I'm going to keep, I just need to pull everything apart, but I'm going to try and reuse what I can and just rebuild what's broken. So let me show you how these gears, how this works. Kind of a nice little system to keep the gear mesh right. So shaft comes in right here with this main drive gear. Whoops. And then it has another gear that drives that big bull gear that sits right here. And then when you come back here, so it drives this shaft. This is the bottom roll, which is usually when you're, on most systems, that's the main force that pulls the plate through. But also both rolls are driven. So to do that, you have a gear inside of here, then you have an idler gear attached to another idler gear that's attached to another gear to the top roll. And what happens is this is a what's the word? This can rotate because these rolls can actually spread apart and shrink down depending on the size of material. So to make sure the gear mesh is always constant, that's what they do. This can move. This one's fixed, but this upper one can actually move up and down to compensate for that. And then this is your bending roll, which is an idler roll anyway, so it won't. We actually on our large set of rolls, this is actually driven also, which helps with larger plate, heavier stuff. This would be totally unnecessary on this, but on our larger roll, we ended up having to put a clutch on this one, because what happens is when you move this roll up to get a tighter bend, even though they're all the same diameter, but that arc length changes, and they all move at different speeds. So it's different in each position, but it's more aggravated when it's closer up. So normally they just let the roll slip, but if you get something hard or it catches the plate or the plate's gummy, it won't slip, and it ends up breaking the gear that drives it. And we had a lot of problems, so we put a clutch on there so it lets it spin without any problems. But it comes through a clutch and then goes through everything else too. So, but I just noticed this didn't have the keyway in it, which is kind of dumb. I don't know why that was missing.
Okay, next step, went and cleaned up the input shaft.
Did some trial fitting. I need to make a key for this. It's 1/4 by 7/8, but I need a tall one. The ones I have out of my kit aren't tall enough. So the next step, I need a bushing in here. I don't know if there was one or if it's just worn down. It's actually still pretty round. So I'm gonna put a bushing in there, because one of the problems, let me bring you around to this. One of the shortfalls of this is the whole mechanism sits here and there's a bolt that holds this from twisting. And you can see how it's been broken out several times before. There's a lot of torque that's put on here when, of course, you're rolling something too big. So, but another thing that adds to that is the input shaft here doesn't fit tight in there. It actually fits tight at the other end, but here it doesn't. Or not super tight, but enough that I can't put a bushing in there, which I don't need to. So I need to put a bushing in here, and this is the end plate. I'm gonna go bore that out and put this bushing in here that holds the far end. Because what's happening is as that input comes through, if that gear mechanism is allowed to twist, it puts stress on everything and causes things to break. So, and you can see on the input shaft, this has been ground down because I don't have the thing. On that gear block, they didn't have anything in there, it's just metal to metal. And I don't know, it was allowed to move because it wasn't tight and it was metal to metal. So it ground down, it wallowed out that hole and did that. So, so next thing is I gotta machine these down to fit in here. I'll probably put some Loctite in there to hold it and bore this out and put this one in here. These work pretty good. They're the right size, so. But I'd rather just bore this out to fit this. Since I can't undo this, that'd be a nightmare. I'll just machine the bushing down. So I measured the bore in that at 1.27, so that's what I'm going to machine it to. Okay, good enough. All right, here we go. Call that good. Got to polish the shaft down a little more. Got a little bit of rust on it. So I didn't want to pound that in anymore. It was, I mean, it's already 1,000 times better than it was. So let's do the end plate. Okay, I'm gonna go sandblast this, get all the gunk off of it, and we'll repaint it. Okay, this is crazy. So I need to make it's called a Woodruff key, but I need it taller. Well, I was trying to find some stock, and anyways, I found this. This happens to work perfectly already, how it's this little stubs machine. So I just need to cut this higher. Needs to be, what did I measure? Half inch tall. And this is 7/8. So I need to mark it half inch up, and I'm gonna cut it and then part it off. It should be good. I just lost the part. I found it. It's under the mess. All right, let's go clean it up. So I just found out, doing some testing, I've got sheared pins in here, or sheared keyways. I've got to pull this whole thing apart. So I have no idea how to do that, so I'm gonna figure this out. I don't know if you can see that upper gear is not spinning. No keyways. How's this supposed to work? It's supposed to make it so the top and bottom roll drive together. No wonder it struggled. Gosh. So, okay, I'll clean everything up. Now the problem I'm running into, this goes in here. You got the two gears. The problem is I'm trying to find my new gears. Because the problem I'm having is these two gears are kind of grabby that go in here. And I got to machine them down. But yeah, I don't like how they mesh. I know they're all it's like they need to be pulled out just a hair, and I got to double check the mesh distance, because they work great in the big gear. It's a really good mesh. So anyways, that's what I got to figure out. But I can't believe there are no keyways in this entire thing. Or there's no keys. Gosh. Okay. Well, luckily I have a bunch of half moon keys, but I gotta clean everything up. I Put that back together. These gears are still good. Gosh, what a pain in the butt. Oh, I am such a dingling. I put the wrong one on. I forgot to put the one on top up first. How does this work? There we go. That's a half moon key. Popped out. I hate these things. There we go. There we go. Now they're rolling together. So I had to cut a special key. Some weird tapers on it because this keyway is all mashed, and I lost. No, I didn't. No. What? No. Oh. Okay. I don't know if it's sitting down far enough. Oh, ha! I forgot to put the rest of it together. Okay. Now to work on this. I can't remember what I decided, but all right, I'll be honest, this thing has gone through about 3 different design changes over the years. Anyways, I kind of forgot how we were originally going to, the second time. Anyways, this is what I ended up with. Also, I think I lost a gear, but that's here nor there right now. So I've got these 2 gears, talked about them. They don't mesh very well, so I've got to figure out the exact, I think they actually mesh good here. So we'll try it. Anyways, I think it works fine. Anyways, these gears are too wide. I've got to machine them down to fit inside of here, but I'm gonna add a bearing, a thrust bearing on both sides, so there's just no resistance and doesn't flop around. I'm also going to, this one's fine. So this is part of the design change I'm not sure about. This one already has a bushing installed into it and it works good for the pin. I'm not gonna mess with this one, I'm just gonna face it off. This one has something in here, I don't know what it is. So I'm gonna machine this out, put a brass bushing in there, because these spin on the shaft. I think this is I don't remember what it's called, but it's oil impregnated iron or something. It's an oilite bearing, but it's iron. Anyways, not really necessary. I don't remember, honestly. But same thing, I gotta face them down. Then this, afterwards, this is where the shaft comes through, and it's all wallered out and gnarly. I'm gonna put a bushing in here to hold that shaft nice and true, because it shouldn't change. I've got to make some adjustments and bracing and stuff on the motor. And then I'm gonna put, even though these will spin on the shaft, I'm gonna put a bushing in here because they're oversized anyways, except for these, but I'm still gonna do it. I'm gonna put a bushing in here and a set screw to hold the shaft, and then we'll go from there. Okay, so I got this machined. Now I have 2 parallel lines to work from. I ended up with .409. I got about a 5,000ths deviation, which is not very much. So now I just need to cut these to the width, plus minus my two, whatever you call those bearings. Oh my gosh, what are they called? Something bearing, and then thrust bearing. With the two thrust bearings, and we're good to go. So I need to machine these down to 1.28 to be tight, but I want a little bit of play. So I'm going to go, let's give it 20,000ths. So I'll just make 1.25 inches. That'll give me a little bit of play side to side. Because I don't want to really put pressure on it. I don't want anything pushing, mostly on this one. But, so 1.25 inches width, and I'm 1.5 right now, so do I have enough in there? All right, so I just realized I have a problem. So the gears that I was using that are too wide, this one attaches to that drive shaft, and it needs a keyway in it. The one I have in the lathe right now has a keyway, but it also has a bushing. So I don't think I'm going to be able to use that one for the drive shaft because I'll lose the bushing, and I don't want to use a split bushing. So I got to go back to this old one, which is already the right width. It's kind of beat up, but that's okay. So this one fits onto the drive shaft, which comes through here with keyway. And then I'm gonna probably end up using this one instead, because it doesn't have a keyway and it doesn't need a keyway, and it's already pretty good. It just needs to be kind of polished out a little bit, which I'll just do that with a hone. So kind of a little bit backwards to what I was doing, but that's kind of the scenario there. So anyways, I'm glad I checked that because I keep forgetting I gotta drive things. So I also gotta make something to hold this one on, something that goes in that end. I probably had something at some point, who knows. I also have this gear. No, that one's too small. Yeah, this one, these are just right. This holder actually moves, so it makes sure it meshes right. But I got to make sure that these mesh correctly because they are a little tough. Anyways, so what I just did was useless. Okay, so I got a little bit of a change again. I was machining this hole, and I made this bushing earlier, and this is an FRP. It's like a Garolite oil. It's not oilite. It's a, anyways, it's a fiberglass reinforced plastic. Very good bearing material. Very heavy duty. Very slippery. Not as for this application, totally fine. I would prefer brass, but I like it. I have it. Anyways, this goes in here on this inside, and it also acts as the bushing for the input shaft coming through, now that I got it stuck in there. And then this flange will act as the thrust washer that I was going to put in. But I realized that on the other side I gotta have I'll have the thrust washer, but I don't have a way to lock in the bushing, and it'll be able to move if, you know, even if I use some Loctite or something, it can still move. So I decided I'm gonna make some more of these to act as my bearings slash thrust washers, and that way they'll be locked in and they can't move, and they're still plenty good enough for this. This one that I just did for the input shaft, I'm gonna have to broach this with a keyway, because the input shaft comes through and I need to clear the key for that shaft, so I can put it together, because there's the keyway on the gear has to, you know, I can't put this in after, so that's what I'm gonna do. I'm so lost on this project. I've changed it so many times, I just don't even know what I'm doing anymore. Okay, so I've got these solid now, and I still have a little bit of play in there, a lot more than I kind of want. It actually feels good. Well, I don't know. That might actually be pretty good. I might pull it in. I think I'm going to move it in about 15 thousandths, maybe 10 thousandths. Just to get a little bit tighter, just because I'm using this older gear. I bet if I put the other gear in there, it'd be tighter. Okay, so the next step is to set up on this hole and then move it over 15 thousandths. I'm assuming these are on the same plane. I'm going to set up on the distance. Well, I don't know. We'll see how far off that is. But I'm going to line up on that hole. I got too much stuff here on the top. Okay, let's pull that out. So my center to center. So my center to center is 2.54 for my gear mesh, and I'm 0.36 off of on the Y direction. So I'm going to zero that, move it over 10 thousandths to get a little bit better mesh, and then actually move it over 10 thousandths, get a better mesh, and then go ahead and bore these out to 1 5/16 to match these. So I went and did some measurements. I went up on the computer and I figured out. So on the computer, this is a 2.5 inch gear mesh diameter, and I measured up here 2.54, and if I measure here with these pushed in tight, it's 2.48. So I'm gonna just do this at 2.5 and move this one up to 0, so I'm straight across, which it doesn't matter. I don't know, I'm kind of torn on it, but this hole's, I don't know. But just to keep the 2.5, because I was going to move about 20 thousandths out from where it is, or 20 thousandths in, because when I measured it, it was a little loose. But I think I'm just going to go to the 2.5 and call that good, just based on what I measured here. So I'm going to do that, move that up to 0, and run it to 2.5, and now I should get a good mesh on here. I just worry about how thin that's going to be when I'm done. Although I'm only going to, it's already 1.125". I'm not going that much bigger. So we'll go to 0. Oh, wrong way. Oh, it's the other way. So yeah, I want to go. Good. That gets me away from. Oh, my slides. Okay, and then I'm going to go to 2.5. The problem is I really can't change this after the fact, so it's got to be good. Close enough. Half a thou is not that much, especially with what I'm working with. Okay, and we just throw this in here. Okay, and my other one. Okay, boom. Oh, that's actually pretty nice. That should mesh nicely. A little bit of play because it's not in the other hole. It's not long enough. Okay. Let's take it out, clean it up, and see how it looks. Okay, so this is the input gear. Still need to broach this one for the keyway on the input shaft. What we got. This goes in here. Come on now. Okay, make sure I did the right one. Yep. Come on now. There we go. Get all the way through. Doesn't wanna. Something's being funny here. Huh. Interesting. It's almost like I'm too. This is weird. Let's see, that looks good. There we go. There we go, that was weird. Oh yeah. Yeah. Grabs a little bit. I got some eccentricity. Don't get my fingers stuck. Yeah, I got some eccentricity somewhere. I'm gonna have to figure that out. do not want to get my finger stuck. Yeah, right there. One of these is grabbing. I don't know. Something on there? Burr or something? Oh, right there. It's where it broke the first time. I wish I didn't have to use this gear, because it is so messed up, but I'd have to buy another one. I don't want to. Looks like the gear tooth's bent. Okay, so I ran into a problem. This gear, the reason why it was grabbing, this gear has a bent tooth, and I don't know if you probably wouldn't be able to see it on the camera, but I guess when this failed, this was the original gear, it bent this tooth right here. And what's happening is once they're bound in their shaft, it won't go. And my problem is, oh, actually it's that tooth. Yeah, that tooth. The problem is I could grind this, but what worries me is now I've weakened the mesh on the gears. So I think what I'm going to do, instead of buying another gear, I have this gear. And I think I'm just going to, I need to clean this up a little bit. I can't get the shaft onto it. I'm going to clean it up, and I'm going to broach that. This has an 1 1/4" bore. I put a sleeve in it at some point. The problem is I might have to weld this sleeve in here. I think it's a steel sleeve, but when I broach it, I might lose that. So let's see what I can do. Let me get it cleaned up first and get it broached, and let's see what happens to that sleeve. It's not a big deal. I just hate having split sleeves in something that's under that much stress. Yeah. Okay, so I got to do this, and I've got to make sure that it is lined up with where it is already. There's already a keyway in there. Okay. Okay, so I'm ready for final assembly. Ran into a few little issues. I got the shaft polished down and put it in. I was gonna just try it off camera, but it started going in. I got about 3/4 of the way there, ended up having to tap it in the rest of the way. It's tight, it's good, it still moves. A little bit of a wear-in time, but good, I like it. I think there's a little bit of a bow on it, but the other problem I ran into is, I had to key this bushing to go over the Woodruff key in here. I ended up having to grind this back of here because now that I have a bushing in there, this doesn't slop around, so it's much harder to get this on. So yeah, I had to grind it down in a few spots just to get past that point. So everything's lined up. I have to do this all in one go with the gear in, and I got to line up the key as I go in. This is going to be fun. I'll tell you what, I don't know how this is going to work, so because I can't see that key. Gosh dang. I don't know what. might, let's see, best way. Oh, I got it. Wow, that wasn't too bad. I went too far. Oh gosh. Okay. We'll get that right on. Yeah, there's a bolt here that holds this from moving. But we got it. And once I get this all put together, I'm gonna put the faceplate on it. Oh, I gotta make a quick bushing to hold that because there's nothing on the cap that holds that on. Actually, yeah, I just need to make a cap for that with a bolt. Once I get running, I think, depending on how it feels, I might put some lapping compound on this gear down through this hole and let it run, just in case I got the gears aren't running nice. The only problem with that is if I have to do that, then I'll have to take it all back apart, clean it down, get that lapping compound out of there. But that's just if I have some bad mesh or something. But as far as that goes, it's on. That was, wow, that went a lot easier than I thought it was gonna go. And so now with the bush, that's the thing is, I didn't realize how much slop that was just to help put that together. And everything's tight now. So depending on how this runs, it might be a little tight. Just with all the bushings now, everything's tight. The problem with, there's tolerances for everything. And I don't know what the tolerance for this was. Clearly they had cast iron bearings. For some reason that one was way oversized on that inside, but the far one's not. Is that wear? Probably not, because it would show on the shaft and there's nothing on the shaft. Or at least to waller out that concentrically. I might be adding a problem here now that everything's nice and true and tight, but I won't know until I start it and try. The trick is to not roll anything thick. This is really only made like 16 gauge, that's 16th inch. That's the most you can put in this. You can get away with something thicker, you know, a 1/4 inch if you're just doing something really thin. You can get away with that. The problem we always had is my guy would come, oh, I broke the rolls again. Because he was trying to roll like a 12-inch wide 1/4 inch plate. I'm like, dude, you can't do that. It will not do that. And you know, oh, I don't know, it just broke. So that's the trick. The other thing we do is we do these rods, and that worked pretty good because it has the grooved rolls on it. But you can't overload them. That's, you know, people wonder why. Anyways, there's a little bit of slop in there. Hopefully that doesn't cause, you can see that move. Hopefully that doesn't cause any problems. That's where a lot of where the gears come out of mesh. That's what happened the last time. That gear was broken because these pulled apart so hard that it just ripped. I can't remember what it broke exactly, but it's been so long. This, when did I take this down? 2018? Actually, we broke it in like 2010, and it's just been sitting, and I wanted to fix it. I've had all these parts for like a decade, and now I'm doing it because I need it for the Go-Kart, but that's a different issue. Oh, the last thing I might do, this is after I get it running. On this gearbox, it's really floppy, and I don't like that. But in order to fix that, I have to redo this coupling, and that takes, I'd have to take it out of here, unbolt it on the back, take all this off, take that sleeve out, and then remake it. Also add some supports in here so this isn't so floppy. It just needs a kicker, probably from here down, to just give it some support, because you can see it's leaning. It needs to be up higher. And part of that is the shaft does hold that. This is just a on-off. You pull this, it goes. Push that down, it stops. So there's no variable speed. I think I'm gonna put a foot pedal on it though. Yeah, I don't even remember how we plugged that in. I don't even have a plug for that. I gotta figure that one out. Oh, I remember now. I did have a foot pedal for it. I do not have the foot pedal anymore. So I've got this scuzzy piece of aluminum. I'm gonna make that end cap for that big bull gear. And I measured, I gotta be 1.25 inches inside, a little bit more for the shaft, a through hole for a 3/8 bolt, and then just over 3/8 extension to hold that gear on. Okay. Okay. So there's 2 pins I have to line up. That one's good. This one's off. Let's see. There we go. That hole's no good. Okay. Huh. Yeah, that's nice. There's 3 bolts. That's all I get. So here it is finished. It's ready to go. These 2 bolts don't work anymore, so hopefully that's okay. Should be. The trick is not putting too thick of stuff in here. This is made for 16 gauge max, I think it's like 3.5 feet. I still need to put some pins in there. Just to run you through the process, you put your plate in here, you tighten these knobs on the bottom to tighten your plate, to tighten it to your plate, so you pinch the plate. It's called a pinch roll. And then you adjust this manually on the back. This pulls the roll up tighter or looser for your roll. Oh, she needs a little grease. And then you roll it. You can adjust as you go, get it tighter and tighter till you get something like this. Then when you're done, of course this would be trapped in here. Pull this up, that bearing, pull this lever down. Oh, see that? And it pops up. Come on, stay up there. And then you can pull your part in and out. Put that back down, lock it, there you go. So, that's it. And I just realized what, I talked about this plug. I thought this ran on 110, but I believe it's set up for 460, which is fine. I actually, in the shop, I have a setup for this on a VFD. So I already have a foot pedal and everything for it. So I just got to plug that on. But that's it. New and improved. Watch me break it. So if you want to see me run this, keep a lookout. I'll be posting a video. I'm moving on to the go-kart again. I'm going to be, just as a little preview, I'm going to be putting my YouTube channel into an expo here where I live. It's going to be, I'm going to just be showcasing some things. I need to get the go-kart done because I'm going to put the go-kart in the expo. Just fun, just somebody I know that does expos, and I asked him for a spot, so I thought that'd be kind of fun, just because I have the opportunity. So the next project is I'm going to be rolling some copper plate for the gas tank on the go-kart. So that's what held up the go-kart for so long. I realized I needed to roll this. I tried doing it by hand, just cranking the end, and it didn't work. It's really thin copper sheet, but it was still too much for this to do it by hand. So that's the next project, so keep a lookout. Thanks for watching. Like, subscribe, and I'll see you on the next video.
Roll. Awesome. That's like. Oh yes. Come on in, Pexto. So